In this video, I'm going to show how to use JMP for multiple regression. The file we're working on is housing prices. We do have the price of the house sold and all predictors, beds, baths, square feet, miles to resort and base, and other predictors. The platform we're going to use is fit model. Under analyze, we'll pass the y or dependent variable and then all predictors as model effects. The personality of the model is set as standard least squares. We can run this model, and as a result we can see the p-value of all predictors. Nearly none is significant enough. We can also look at parameter estimates. If you right click on this table anywhere and from the list of columns, click on VIF, variance inflation factor, we can see some of those variance inflation factors are really high, 13 and 14. Any variance inflation factor more than 5 is associated with an 80% or more correlation between predictors. If that's the variance inflation factor more than 10, indicates 90% or more correlation between predictors, which is not a good thing. High correlation between predictors will create unstable variances and wrong results. So I will close this window and go back to identify high correlations between predictors. Under multivariate methods, multivariate, we can create a correlation matrix. All predictors plus price, all in the same box, Y columns, and click OK, and you can see the correlation matrix. Now, this correlation matrix shows correlation between pairs of variables, including the dependent variable price. Any correlation more than 80% or 90%, depending on what level we consider, is too much of correlation. As we can see here, nearly 95% correlation between two predictors, miles to resort and miles to base. That's too much. We have to remove one of the two. So if we have removed, for example, miles to base, then miles to resort may not have high correlation with the other predictors. High correlations with price are okay. The first column or the first row, if you look at them, you can see these are correlation with price, with the factor we're going to predict, and they are okay. To see which one of these two predictors, miles to resort and miles to base, have a higher effect or higher partial correlation with price, we can use matrix of partial correlations. In partial correlations, you can see the effect of each one of those variables on each other, isolating from the effect of others. So the first column, which shows the correlations of all predictors with price, focus on the correlation of these two, miles to resort and miles to base, regardless of the sign of the number, which one has higher partial correlation with price. So we can see miles to base has a slightly more correlation, partial correlation with price. So we can keep miles to base and remove miles to resort from the system. Here the two variables show very close partial correlation with price, so practically makes no difference which one we keep in the system. So we go back under fit model, add the price, and all predictors but miles to resort. Add them as model effects. One more change we need here. Change the personality of the model from standard least squares to stepwise. And run. With stepwise regression, we'll start with all variables in a model or no variable in the model, depending on which way we go. We go forward or backward. Then adding or removing variables one at a time to find out which variables are showing more correlation with the response, the price here, and which one is not significant. So when no variable is in the model, we go with forward stepwise. So we can click on go. We see a number of trial and errors, and we can check every single of them down here. After all these trial and errors, the system tells us there are 4 variables that are significant. We can make the model and then run the model. In this model, we can see the significance of the 4 variables. P-values are small. The last one, these are sorted based on the p-value, square feet. P-value of 0.0292, at least significant at alpha 5% level. Also, under parameter estimates, same p-values for all factors. Now, under the top drop-down, we can look at factor profiling and profiler, which shows graphically the significance and effect of each one of those predictors. You can see the price on the left side, which is the response, and the red number is the estimate of the price at the level all other variables are, and then 2 other numbers, 95% confidence upper and lower levels. If we change the value of the variables one at a time, for example, change the square feet, grab the vertical red line, click, and move it, we can see how the price is changing, and probably slight change at the significance level of other variables, while the value of the other variables, the vertical lines, are fixed. If we change one variable, for an estimate of the price based on these 4 factors, we can go back to the drop down and save columns, prediction formula. Now we have saved the prediction formula to the table. This is the prediction formula. If you scroll down, for those 4 variables we have in the model, if we enter values in the first blank row down here, we can have an estimate. For example, if there's a house with 3 baths, 2,000 square feet, 8 miles from the base, and it's on a 1/4 acre land, immediately after entering the last number, we can see there's an estimate of the price right here. This is how stepwise regression works in JMP, and this is the automated method. Now we do a backward stepwise regression. Go to Analyze, Fit Model, Price, and all predictors, but must resort to take care of the multicollinearity, add them as effects, do stepwise, and run. We have 2 buttons here, enter all and remove all. We'll click on enter all variables are in the model. We start the regression analysis with all variables. Remove all, which is the default, no variable is in the model. So if you're going to do a forward stepwise regression, this is default. If we enter all variables are in the model, and we change from forward to backward. It means we'll remove the variables one by one if they're not significant. If you click on go, In this case, the result is the same. So in the backward, the 4 significant variables are the same as we got in forward.